we are going to consider the capacitors are connected in parallel. So there are three capacitors, C1, C2 and C3. They are connected in such a way that the positive plate of each capacitor is connected at one point and negative plate of capacitor is to be connected to other point. And across such combination we are going to connect a potential difference of V, so that this potential difference V sends the current I. That current I will come up till junction point A, and at junction point A your current will get divided into three branches. If the current will get divided into three branches, then according to definition of current is equal to charge upon time. So if current factor will get divided, means charges will also get distributed. So we can say that on first capacitor C1 charge distributed is Q1, on second capacitor charge distributed is Q2, and on third capacitor charge distributed is Q3. And correspondingly on negative plate I can say on first capacitor charge is minus Q1, second capacitor charge is minus Q2, and third capacitor the charge deposited is minus Q3. Means what happens here? In parallel combination the charge distribution is different. So that is our first important point, that is charge on each capacitor is different. But now what is the thing? Across C1, C2 and C3 potential will remain same as a V. So the potential will remain same. So potential will be same. Now as the charge Q is different, means what I can say that I can write down charge Q is equal to Q1 plus Q2 plus Q3. And now we are knowing that in the definition of capacity C can be written as a Q upon V. Means I can say that charge Q is equal to C into V. Now if charge deposition is Q1 on capacitor C1, potential is V. So for Q1 I can write down C1V. Similarly for Q2 I can write down as a C2V, and for Q3 I can write down as a C3V. And now this value of Q1, Q2 and Q3, now I am going to substitute in the equation. Q is equal to Q1 plus Q2 plus Q3. So now that equation of charge, now it will become as a charge Q can be written as, instead of Q1 I can put C1V, instead of Q2 I can put C2V, and instead of Q3 I can put it as a C3V. In that now V factor is common, so V is taken common, so inside the bracket C1 plus C2 plus C3. So now I can write same equation as a Q upon V. This voltage or potential factor I will take it for division in the opposite side, which is equal to your C1 plus C2 plus C3. And we have this formula, C is equal to Q upon V. Here I am getting Q upon V, but Q is a charge, total charge deposited on parallel combination, and V is the total potential applied across parallel combination. So instead of Q upon V, I can write down Cp is equal to C1 plus C2 plus C3. So this is nothing but your equivalent capacitance in case of a parallel combination. So now in your equivalent capacitance in case of parallel combination, we have certain different points to be remembered. In that, what is the first point? The charge on each capacitor is different. Second point, potential is on each capacitor will remain same. If charge is different, so I can say that Q is equal to Q1 plus Q2 plus Q3. And here from the formula C is equal to Q upon V, I can substitute the values of Q1, Q2 and Q3. And when I substitute this value, I will get it. The equivalent capacitance in parallel combination is equal to C1 plus C2 plus C3. Now, in the previous lecture, we have seen the series combination. And in series combination, what we have said that CS is equal to nothing. Sorry, 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is our equivalent capacitance in series combination. And here I am getting equivalent capacitance for parallel combination. So if you observe these two equations, so what our conclusion is there? That is, parallel combination is used to increase the resistance, and the series combination will be used to decrease the capacitance. So this parallel combination can be used to increase the capacity of the circuit, and series combination can be used to decrease the capacity of the circuit. Now here for CP and CV, for this parallel combination, if I am going to connect n capacitors, value of each capacitor is same, means C1 is equal to C2 up till Cn is equal to C. So if I put that value, I am getting Cp can be written as a Nc. And already in the previous lecture we have seen this 1 upon Cs can be written as N upon C if your number of capacitors C1, C2, C3 have the same capacity as the C. Means I am getting this as a equation A if n capacitors are connected in series, and this equation I am getting as a B when n capacitors are connected in parallel combination. And now if you take this ratio of this Cp and Cs, if I am going to take the ratio of these two equations, now in that ratio I can write down this A equation, I can write down as a Cs is equal to C upon N just by cross multiplication, and here our Cp is equal to nothing but Nc. And now if I take ratio of these two value, then I can get it as a Cp upon Cs. So Cp upon Cs means Nc upon C by N. So this Cc factor will get cancelled, and I am getting as a Cp upon Cs can be written as a N square. So this is nothing but the relation between the equivalent capacitance in parallel combination to series combination is equal to N square. So in this lecture you have to remember these certain formula. One formula for Cp, another formula for Cs, and third formula is relation between Cp and Cs. Thank you.